Welcome to Click My Project. Self-learning classifier for internet traffic. Many classifiers are for web traffic using clustering. It's a modified title. Then abstract. It uses unsupervised algorithms along with an adaptive learning approach to automatically let classes of traffic emerge to obtain a high performance statistical feature. SeLeCT classifiers allow that proper class labels can be easily discovered, provide optimal classifications, accuracy and time consuming. Accurate traffic classification is of fundamental importance to numerous other network activities from network monitoring. The proposed system overcomes the limitations of iterative classifiers. The semi-supervised classifiers are using the internet traffic and also overcome the internet bots. The novel algorithms are also used in this process and it performing to split the traffic and reduce the bots. The iterative filtering and multi-batch seeding to improve the performance. Data flow diagram. First, get input. Get input means we are going to get the data. Then data pre-processing. Data pre-processing means we are going to remove the unwanted data. Then clustering. Clustering means we are going to grouping the data from the data sets. Then rule reductions. We are going to apply some rules to reduce the clustering data. Then traffic reductions. Traffic reductions means we are going to reduce the traffic from transfer the data from one to another. The traffic reductions is going to move to k-means clustering. Clustering means we are going to cluster the data using k-means algorithms. If no means we are going to homogeneous clustering. Now I am going to run the project mining classifiers for web traffic using clustering. This is a modified title and I am clicking the enter button. It moves to next frame. It has browse, load and show. First I am getting the data sets. I'm getting the data sets and load to database. Next, data pre-process. It moves to next frame data pre-processing. Pre-processing data. Here I'm getting pre-processing data. Next I'm going to classify the data. And here clustering the data. Just split the data from cluster 1, cluster 2 and cluster 3. And I'm clicking next button. It moves to next frame. Here I'm having network packets, extract the rules and apply the rules. Here I'm getting the network packets data. Network packets data, it has a telnet, HTTP, AUTH, SMTP, like that. Here I'm extracting the rules. Then I'm going to apply the rules. This is on source data from original data. Here I'm getting the extracted packets from using the rule 1, and next rule I'm going to get here. So that means original data, then prefix based data using second rules, then next rules some ternary based rules. In some original data, here I'm using the third rule. I'm clicking next. It moves to next frame. It has a load rules updating database. Here I'm going to load the data and update it into database. Here I'm going to pre-processing. Then homogeneous clustering. Here I'm going to get the homogeneous clustering, cluster 1 and cluster 2 and cluster 3, like I'm going to get the data. Then I'm going to classify the data and I'm going to move next frame. It has a maximum and minimum values using k-means clustering. Here minimum point of values I'm getting. Here I'm going to get maximum values. Then minimum and maximum values I'm going to get. That means a cluster 1 and a cluster 2. Next I'm clicking the next button. I'm going to compare the distance from existing and proposed values. Thank you.